Hello my dear students, welcome back to NEET World. So we are very happy to launch this IPE sessions, and also guys, we are providing this IPE study material, that is C60 by 60. I mean, this is a booklet made for scoring 60 out of 60 in your IPE exams for both first year and second year for both Telugu states. Okay, now you can access this material at free of cost from our NEET World app. Okay, go to Play Store and download NEET World app. Okay, so from this app you can access this free study material and just say hi in the chat box. Our team will share this particular material for your preparation. And guys, not only chemistry, so we have physics, biology as well as mathematics if you are MPC background. Okay, for BPC background you have biology also along with physics, chemistry, right? So all these materials are available at free of cost. Now you no need of worrying about list of important questions and explanation of each and every question. So again about blueprint as well as model papers, no need to worry about any of these things because we are providing all these things at free of cost. Nowadays if you go in and check in the market, there is no proper material available for your IPE preparation which gives you complete things together right now. So that's why we have planned to make this material and make it available for each and every student, whether he is from rural, urban or from wherever the part of the whatever the part of this Telugu states. For all these students we are providing this at free of cost. Just download our app and there you can access our free materials for your IPE preparation. And guys, we are, and I think you are following us regularly, you know that we are coming up with free live sessions for IPE exams by using these study materials itself. It means we from our NEET World Institute only providing this, right? So each and every question that is included in this material, see here, very important LAQs, SAQs, very short answer type questions we are providing, right? So along with the questions, answers also clearly explained in the book. Okay, now what we are doing here in these free live sessions, we are explaining each and every question of this LAQ, SAQ and very short answer type question with a proper explanation. Okay, you just join our YouTube channel, I mean in the live sessions, and you just listen to our words that are from this material. Okay, each and every word or each and every line from each and every question of this book is clearly discussed here. So what to do? Download the material, keep it in your hand and look at the discussion that we are doing here. So this is more than enough for making your preparation more effective, more productive to score very good marks in your IPE exam. Okay, I hope you got everything that whatever we are planned to do for your IPE preparation, right? So if you really like this strategy from our side, just click on the like button and follow us by clicking on the subscribe button. Okay, right. So now here in the last class I have explained LAQ questions, LAQs of first year IPE right now. So we have covered structure of atom, it means Bohr's model and quantum numbers is completed, and the next classification of elements, that is periodic table, is also completed, and the next we have started discussing about organic chemistry reactions also. Okay, so here also we have covered 3 questions right now. Till now we have covered 3 LAQs from this organic chemistry. Right, now in this session we will be covering the remaining questions of these LAQs from organic. Then we have very few chances to get a LAQ from chemical bonding. I hope you know what are the 3 chapters we can expect that LAQ, like 8 marks question. I hope you know that it can be from structure of atom, or it can be from periodic table, or it can be from organic chemistry. If not from organic chemistry, that comes from chemical bonding right now. So now we completed these 2 chapters very clearly, and organic chemistry also completed, and today we will be ending up with the chapter, and the next we will be beginning this new chapter, that is chemical bonding, after completing organic chemistry. Okay, right guys, do not worry that the list of questions may be discussed more or less. Do not worry about this because we have covered all the important questions that are come asked in the previous papers. If not in 8 marks, the same question can appear in the 4 marks. Okay, so this is the only motto to score, I mean only motto to discuss each and every question, that every student to score 60 out of 60. So this is the motto of our NEET World Institute, as well as this preparation or to making of this C60 booklet also for chemistry, P60 for physics, as well as biology and mathematics 75. Okay, right. So now what to do? You just click on the subscribe button and also go to Play Store after this session and download this NEET World app and access our free content. Right. Now look at this. So these are the things we discussed in the last session. So in the last session I have covered up to give like methods of preparation of ethane and its chemical reactions right now. So guys, if you download the material, it will be like this. See, it will be like this because this is itself a material page. Okay, so now see, every line here will be dictated, will be clearly explained here. Okay, so no need of worrying about your preparation or explanation from someone, because here we are to provide everything. Okay, right. So just if you have any confusions or any doubts while understanding the topic, while discussing the topic, just mention in the chat box. So we will be looking into it and we will be making it clear. Okay, right. The next here, the question will be, how do you get benzene from ethylene? So is it clear or not on the screen whatever we are writing? Yes. Yes, let me check everything is clear whatever we are writing on the screen. Yeah, guys, look at here. What is the first question given here? How do you get benzene from ethylene? And explain halogenation, alkylation, acylation and nitration, sulfonation of benzene with equations. Very simple. Once after discussing this complete answer, then you will feel confident that you can able to answer this in the final exam also. So just see what do we mean by ethylene first. Ethylene is nothing but ethane only. What is that? Ethylene is nothing but ethane only. So now what is the structure of ethylene? So you can write it as C triple bond CH. Okay, like this. So these will be now converted into benzene. Okay, for this purpose what to do they are asking. Okay, see how do we get benzene from ethylene? So we need to get benzene from ethylene. Okay, for this purpose we will be taking 3 molecules of ethylene. How many molecules? 3 molecules of ethylene provides 1 molecule of benzene. Okay, so for this purpose we require high temperature like 600 degrees Celsius. So and copper metal will be used here. Okay, copper tube. So look at here, ethylene is prepared. Ethylene is passed through red hot copper tube, through what we can pass this to the red hot copper tube at 600 degrees Celsius. Now what happens? The molecules of ethylene get condensed to form benzene. So this ethylene molecule will get condensed and that gives your benzene. Okay, so if you wanted to explain it more clearly, just write 3 molecules of ethylene here like this. Like this you just represent 3 molecules. Okay, so after clearly giving the structures of 3 molecules of ethylene, just make a cyclization between them. So what happens? This pi bond will be shifting between the 2 carbons, like adjacent molecules. Okay, when it is shifting, this pi bond will be shifts over here and the next it will be going over here. So now what we are seeing, 1 2 3 4 5 6, a 6-member cyclic ring is forming now. So this is how a 6-member cyclic ring is formed. Okay, so now what is this? This is nothing but our benzene. Okay, so benzene is produced from ethylene through passing this ethylene gas on red hot copper tube, okay, at 600 degrees Celsius. That's it. So this is what the first line you need to be clear with, okay. Then next, what they are saying, chemical reactions of benzene. So what are the chemical reactions shown by this benzene, they are asking, okay. First part of this question is over. From here to here it is over, okay. So what is the next part? Explain halogenation, alkylation, acylation, nitration, sulfonation, okay. This is the second part. First of all, chemical reactions of benzene with halogenation. First of all, with halogenation, okay, it means benzene is now treated with halogen, okay. So now what will be the product formed here, they are asking. For example, what are the halogens, you know, chlorine, bromine, fluorine, iodine, like this, you know. Now let us say here I am taking chlorination. It means you should take Cl2. This is our halogen here, okay. So now chlorination of benzene we can call, what we can call? Chlorination of benzene. So chlorination of benzene provides chlorobenzene. What it will provide? Chlorobenzene. So it will be like this, chlorobenzene is produced. For this conversion, along with the chlorine, we need to use a Lewis acid here, okay. What we need to use? A Lewis acid, like anhydrous AlCl3 should be taken. What I am saying? Anhydrous AlCl3. So it is better to mention in this way instead of mentioning like this. So just to provide this material in a smoother way, we have designed it like this, but in the exam you just try to mention in this manner, so that examiner, like whoever correcting your paper, will get impressed by your representation and he will give full marks, okay. So now what is happening here? Benzene react with chlorine. See, benzene react with chlorine in presence of anhydrous AlCl3. In presence of what? Anhydrous AlCl3 to form chlorobenzene. Yes, this is called what? Chlorobenzene. So here at the bottom of this you can write benzene, okay. So this is chlorine molecule, okay, forming chlorobenzene, okay. Benzene is now converted into chlorobenzene, okay. You need to write in this way. And what is a byproduct formed? Say, out of these two chlorines, only one chlorine atom is here right now, and on each of this benzene carbon there will be one hydrogen. So that hydrogen that is replaced by chlorine now, so that that removed hydrogen and extra chlorine of here forms HCl gas, okay. So this is what the byproduct. That's it. How easy it is? Easy, right? Yes guys, those who felt it is really easy, just click on the like button. Click on the like button so that this will be recommended to the other students who are preparing for your IPE exam like you. Right. Now look at this, what they are saying next. Friedel-Crafts alkylation. Friedel-Crafts alkylation means here benzene reacts with alkyl chloride. What is that? Benzene reacting with alkyl chloride, okay, that is CH3Cl, like methyl chloride, ethyl chloride, like that, okay. In presence of, again, in presence of anhydrous AlCl3 only, like previously we have made na, same thing you can take here. So benzene reacting with methyl chloride or any alkyl chloride in presence of AlCl3, that should be anhydrous form. It means no water. That's why we are saying here anhydrous AlCl3 means absence of water, only AlCl3 is present, okay. So AlCl3 to give alkyl benzene, that is nothing but if I am using methyl chloride, it will be giving toluene, okay. Just look at here what I am writing. Structure will be represented like this, benzene plus methyl chloride CH3Cl, and here anhydrous AlCl3. It means you have an empty vacant orbital with this aluminum of chlorine, aluminum chloride. So to this empty orbital of aluminum, the lone pair electrons of chlorine donated, so that see this chlorine atom goes out, okay. What you are getting here, methyl group, no, so that will be substituted onto this benzene. That's it. So no need of explaining all these mechanisms and all. What to write? Benzene plus methyl chloride in presence of anhydrous AlCl3 gives a methyl benzene, like this you can mention CH3, that's it, methyl benzene, that's it. This is a way of representation in your exam, okay, that's it. Okay, now what is the byproduct here also? Here also HCl gas is released, that's it. Okay, next, look at the next one, Friedel-Crafts acylation. What is the next third reaction here? Friedel-Crafts acylation. So what they are saying, benzene react with acyl chloride, okay, acetyl chloride okay, it means acyl chloride, acetyl chloride here is nothing but CH3COCl. So this is called acetyl chloride. So I will tell you one simple trick what to do here in presence of, for all these reactions I will be giving you one simple trick, but you should not mention tricks in the exam. You should clearly demonstrate the reaction, then only they will give you full marks. This is not a competitive exams like JEE, NEET or EAP set. This is purely IPE now. So they will look at your presentation, how effectively you are presenting during the exam. Okay, so it is better to give a clear, elaborate and with a good handwriting and good presentation, then they will be getting a good marks in your like in the final exams. Okay, so do not give any shortcut ways, try to make it as much as clearly possible, because they are looking at your presentation along with your answer. Okay, they won't want your logics and they won't want your tricks during the exam, especially during your IPE exam. Okay, so that's what I am suggesting you, not to give any shortcuts, follow strictly a traditional method of good presentation of your subject, okay, your knowledge. Okay, because that person may only check for the things that they required, okay, not what you know. Okay, so now look at here, benzene ring will be there. To this benzene what we are adding, methyl COCl. So this is acetyl chloride is there. So now what happens is, in presence of anhydrous AlCl3, what? In presence of anhydrous AlCl3. Now what happens on this benzene ring, just insert this part, just insert this part. What is that part? So just write benzene, on this you are inserting C double bond O CH3, that's it. This is what you are doing right now. So during this process what is removed here? So you this chlorine is removed. So if you observe, you can have a tricky way to remember. Whenever there is halogen with AlCl3, whenever there is a halogen with AlCl3, again whenever there is a halogen with AlCl3, that halogen is removed. Okay, the remaining part out of these two, one chlorine is removed, the remaining part, another chlorine here, this alkyl group here, this acyl group here will be attached to our benzene ring, that's it. So see, everything is same here. See here, this acyl group is attached to the benzene ring, this alkyl methyl group is attached to the benzene ring. Here out of two chlorine, one chlorine is removed with this AlCl3, another chlorine is attached to this benzene ring, that's it. So that you are getting respective products right now. So you got here acetophenol. Okay, what you got? Acetophenol. See, this group is called acetyl group. So acetophenol you can say. What you can say? Acetophenol. Okay, so simple Friedel-Crafts acylation. It means benzene upon reacting with acetyl chloride in presence of AlCl3, anhydrous AlCl3, gives acetophenol. What it will give? Anhydrous AlCl, in presence of anhydrous AlCl3 gives acetophenol, that's it, that's it. This is your reaction here, that's it. Here up to here it is clear now. Then next, nitration reaction. What next? Nitration reaction, very easy. Nitration and sulfonation are also very easy. See, if you have planning to prepare for at least for your EAP set or JEE NEET exam, these reactions are very common reaction that you will be playing every day, like any organic chemistry. If you are doing any chemistry, so definitely like any organic chemistry part you are exploring to solve some questions, definitely you will be familiar with some of these reactions, at least not full, at least some of these reactions, because all these reactions are very regular reactions in your IPE like JEE, NEET, EAP set preparation. Okay, so that's what I am saying here. Just look at here, take your benzene ring here. To this we are adding nitro group. What do we mean by this nitration? To the benzene we are adding nitro group, that becomes nitrobenzene now. So nitration means nitrobenzene, you should remember. Okay, benzene converts into nitrobenzene, that is what nitration means. Okay, chlorination means what? Halogenation means on benzene we are adding halogen, that is what halogenation. So if I am saying chlorination, benzene becomes chlorobenzene, that's it. Okay, if I say alkylation, like methyl group methylation, so on benzene ring you need to add methyl, so that is methyl benzene. Okay, so here what we are doing nitration now, so just benzene converts into nitrobenzene. But for this conversion, what is a suitable reagent you need to take here? So that is nothing but, here you should take concentrated HNO3. What to take? Concentrated HNO3 plus sulfuric acid mixture should be considered here. What are the two things we have to take? Concentrated HNO3 plus sulfuric acid mixture. So this temperature mentioned here is 60 degrees. How much temperature? 60 degrees. That's it. So if you mention it in this way, you will be getting full marks, okay, for this nitration. And you know, if you want an extra part to be mentioned, you can mention here electrophile is, here electrophile is, you can write fully, electrophile is NO2 plus. What is electrophile? NO2 plus. It means from this HNO3 and the sulfuric acid, you are generating an electrophile. What is the name of that electrophile? Nitronium ion. This nitronium ion is generated. This electrophile attacks on our benzene ring and generate this nitrobenzene compound. Okay, this is what the mechanism you can mention. Just a sample things you can mention, if not in detailed mechanism. Okay, the next one is, what they are asking. Just look here what they are asking. They are asking about sulfonation. So similar to nitration, here we can say sulfonation. So take the benzene ring and the conversion of benzene to benzene sulfonic acid. It means benzene, on this you are adding SO3H. Okay, so that's it. Benzene converting into benzene sulfonic acid. For this purpose, here you need to take oleum or fuming sulfuric acid. What is that? Fuming sulfuric acid, we can say fuming sulfuric acid. Okay, now if you want to mention it more effectively, just mention the electrophile involved here is SO3, sulfur trioxide. That's it. These are the 3 points you mention, and that is more than enough here. So all 5 reactions are discussed. Okay, so now if you have any doubt, please ask me in the chat box from these 5 examples. What are the 5 exemplar reactions? First one is preparation of benzene from ethylene. Okay, that is nothing but 3 molecules of ethylene condenses or polymerization, cyclization to give benzene. Okay, so this happens in presence of red hot copper tube, okay, at 600 degrees Celsius. Okay, after this preparation of like chemical properties of benzene. So what are the chemical properties? First one is halogenation, next one is alkylation, next one is acylation, next one is nitration, and after that sulfonation. So 5 reactions are over along with its preparation right now. So if everything is clear, just click on the like button. Okay, so that we'll move forward with one more concept or one more question here. Again, one very important statements here, because this statement is not only useful for your IPE but also for your EAP set, JEE, NEET exams. So what they are saying, explain or discuss Markovnikov rule and Karash effect, or instead they may say anti-Markovnikov rule. Okay, Markovnikov rule and anti-Markovnikov rule or Karash effect they will ask in the exam. So what do we mean by Markovnikov's rule? Okay, it is very simple. I will explain, listen here. So this effect or this rule applicable for alkenes. What I am saying, this rule is applicable for alkenes. And which type of alkenes? This will be applicable for unsymmetrical alkenes. Which alkenes? Unsymmetrical alkenes. Which alkenes? Unsymmetrical alkenes. Okay, now I will tell you what is symmetrical and unsymmetrical. See, on these carbons, if the attached groups are same, then we can say symmetrical alkenes. But one side different alkyl group, other side different alkyl group means, see, here I am writing alkyl group, hydrogen, this side only 2 hydrogens. So it means on this carbon we have one alkyl group, this side no alkyl group. So you can say this is a example of unsymmetrical alkene. What I am saying, example of unsymmetrical alkene. Now these unsymmetrical alkenes, see, when an unsymmetrical alkene, like whenever unsymmetrical alkene is taken here, what I am taking, unsymmetrical alkene is taken. To this we are adding unsymmetrical reagent. To an unsymmetrical alkene we are adding an unsymmetrical reagent. What do we mean by unsymmetrical reagent? See, symmetrical, unsymmetrical. Here HBr I am writing. So how this HBr will breaks, like bromide is more electronegative, so it will create bromide ion and H plus ion by taking these electrons towards bromine right now. So whenever there is heterolytic cleavage, it means, see, this bond contains 2 electrons, one from carbon, one from hydrogen and 1 electron from bromine right now. If the 2 bonded electrons are taken by only 1 atom, we can say it is an unsymmetrical cleavage. So whenever there is unsymmetrical cleavage, it will generate a negative charge and a positive charge like this. Okay. So now when an unsymmetrical reagent is added to alkene, what I am saying, an unsymmetrical reagent like HBr, HCl, H2O, etc. are added to unsymmetrical alkene. Which alkene? Unsymmetrical alkene. The hydrogen atom of this unsymmetrical reagent, what I am saying, the hydrogen atom of this unsymmetrical reagent attaches to the carbon that already has more number of hydrogens, and other part, that is the negative part, goes to the carbon having fewer number of hydrogens. It means very easy. Look at here, what I am writing, just follow this, then you will easily get the concept here. See, the reaction will takes place only on these alkene carbons. It means only the double bonded carbons only. Okay. So to this what we are adding? We are adding H and Br. Okay. So now what do we mean by Markovnikov rule? Means the hydrogen atom of this unsymmetrical reagent goes to that carbon of alkene which has more number of hydrogens already. Here how many are there? 2 are there. On this carbon how many are there? Only 1 hydrogen atom is attached now. So more the number of hydrogens, there the hydrogen atom of this reagent, HBr reagent, will be attached. So it means you are making this CH2, CH, CH3 is there now. So on this carbon you are adding this newly coming hydrogen from this HBr. So that is what I am adding here. Now the other part, this is called negative part of this adding molecule, will goes to the other carbon of this alkene carbons. So it means here you can add Br, that's it. This is what the Markovnikov rule says. Okay. So once again make the statements, when an unsymmetrical reagent like HCl, HBr, H2O is added to unsymmetrical alkene, both of them are unsymmetrical only. Unsymmetrical reagent is added to unsymmetrical alkene, then the hydrogen atom of this unsymmetrical reagent goes to more number of hydrogen containing carbon, whereas the negative part of this molecule, adding molecule, goes to less number of hydrogen containing carbon of this alkene. Okay. Hope the Markovnikov rule is clear right now. Now what do we mean by Karash effect or anti-Markovnikov rule? It is Markovnikov rule and this is anti-Markovnikov. It means opposite now. So it means the addition of these parts will be reverse manner. That's it. Okay, reverse manner. Okay. So first of all, be clear with this statement. Once pause the video and try to write it on your notes, like on your own. Just try to take one empty sheet and try to write on your own, so that you can confirm that you are clear with this explanation first. Okay, right. And after this we have Karash effect. Now let me explain this. What Karash effect says here, just see, in presence of peroxides, like peroxides, in presence of peroxides, the addition of HBr, again here what, HBr to unsymmetrical alkenes takes place in opposite direction to Markovnikov rule. So whatever you have followed in the previous discussion, it will be reverse of that or opposite of that. What they are saying, in presence of peracid or peroxide, what is that? In presence of peroxides, okay, peroxides you take addition of HBr, what we are adding? Addition of HBr to alkenes, to what? Alkenes, okay, to this alkene we are adding HBr in presence of peracid, okay. Now what type of product is formed, they are asking. So previously we know hydrogen goes to more number of hydrogen containing carbon of this alkene right now. So it means hydrogen comes here and bromine goes here, but here it will be reverse, okay. So it means reverse means hydrogen goes here, bromine comes here, that's it. The product formed will be like this, okay. Previously the product is formed like this, now product is forming like this. Now what they are saying, what is the difference between them? There is no peroxide in the previous discussion, Markovnikov rule, but here you have peroxide, peroxide bond now. So due to the presence of these peroxides, the addition of HBr is different in this case compared with the previous case, okay, because it follows free radical addition mechanism. What is that mechanism called? Free radical addition mechanism. See once again you need to mention this statement perfectly to get maximum marks first. Instead of writing this, first you need to write this, but before that you need to mention this explanation. What they are saying, theory part, in the presence of peroxides, the addition of HBr to unsymmetrical alkene takes place opposite direction to the Markovnikov rule, takes place opposite direction to the Markovnikov rule, okay. So here the bromine atom attaches to the less substituted carbon, where it will be bromine atom goes to less substituted. It means on this carbon less number of alkyl groups are there, now only hydrogens are there. That is what mean by less substituted or more number of hydrogen containing carbon means, okay, that's it. So explanation, what is the mechanism you can mention? Yeah. So look at here, it follows free radical addition mechanism. What mechanism? Free radical addition mechanism, addition reaction, free radical addition reaction. So what it says? Step 1, initiation. What is that initiation step? See, two RO radicals are formed from this peroxide. So what is the duty of this peroxide in the reaction? First of all, this peroxide bond will cleave into two equal halves. Why it is breaking into two equal halves? Because both sides oxygens only now. So this bond is weaker because of lone pair repulsions of this oxygen. So due to this reason, since both atoms are same only, the bond will be cleaves into two equal halves. Bond cleaves into two equal pieces. Now what you are getting here? OR dots. This dot indicates the electron coming from this bond, okay, like this. So how many species you are getting? Two radicals are generated, okay. Now these two radicals, what they will do is they will take one proton. So this OR radical will take one hydrogen atom from HBr, okay. See, dot means one electron is present and one more electron from this bond of HBr will be taken by this OR radical and forms ROH type of product, and this Br become Br radical, Br dot, okay, you got Br radical, okay. So now that Br radical will be attacking on our alkene. Where it will be attacking? That will be added to our alkene. So this radical will be attached to this terminal carbon, so that from this bond one electron is taken by the chlorine and to make a bond like this CH2Br type, and the next one more electron of this bond will stays as a dot here on the center carbon. So this is a secondary carbon radical now. So secondary carbon radical is more stable than the primary radical. That's why this kind of addition is taking place, okay. So now this radical again takes hydrogen from one more molecule of HBr, finally gives you this kind of product, okay. So CH3, CH2, CH2Br, okay, this is a product formed and bromine is produced here. So first step is called chain initiation step and second step is called chain propagation step. Next, chain termination. How this chain termination is taking place? Whatever the radicals formed during the reactions, they combine themselves and reaction will get stopped, okay. Two radicals combine and stop the chain, that's it. If you mention like this, yes, it is perfectly good. Next, one more condition, why only HBr shows this Karash effect? See, anti-Markovnikov rule, see, previously studied about Markovnikov addition reaction, right now. So this is shown by all unsymmetrical reagents like HBr, HCl, H2O. Like this we have written different reagents, unsymmetrical reagents, but this anti-Markovnikov rule, Karash effect, is shown only by HBr molecule, not by any of the other like HF, HCl, HI. They won't show this kind of addition. Only it is possible for HBr. Okay, why? Because for HBr bond enthalpy is negative. For all these things bond enthalpy is positive. So due to this reason, enthalpy reasons, bond energy reasons, what is the reason? Bond energy reasons, HF, HCl, HI do not participate or do not show this anti-Markovnikov rule or Karash effect type of reactions. Only possible with HBr. Okay, hope this discussion is also clear. Guys, those who are in the live sessions, just click on the like button and you can interact in the live discussion in the chat box. See, the comment box is waiting for you. You can write your doubts and we'll be looking into it and I will be getting clear your doubts. Okay. Right. Let me take some water first. Right. And after this, this is about Markovnikov rule and anti-Markovnikov rule addition. Okay. So now this is about NEET World Academy. Here we have specially designed classes for NEET, JEE and EAP set exams. Okay, as well as a supportive sessions for your IPE exams also. Right now, see, we will be conducting NEET, JEE classes every day regularly along with EAP set classes, and you know, now this is a high time for IPE exams now. So those students who are really looking for help for this IPE preparation, yes, we are providing them this free IPE exam strategy for preparation and support for their preparation. Okay, right. So if you want to join with us, you know, in your preparation for NEET, JEE or EAP set, you just go to the description box. There the details of our NEET World Institute will be provided. You can come for online, offline first. Offline will be in Hyderabad, okay, Narayanguda, and if you are not willing to join offline, you can also opt for online classes that will be conducted through our MedWorld app. Okay, so MedWorld app, it will be live plus recorded versions. Okay, right. So it's completely up to you. So what type of course you are choosing and what type of batch you are joining, whether offline, online, everything. But detailed information, if you want a detailed information or any guidance related to the choosing of batches, choosing of proper career or career plans, just contact through the mobile number which is given in the description box. Okay, right. Next one is, let us go through chemical bonding also, because chemical bonding, there are some chances to ask from chemical bonding also right now. So that will be giving you the LAQs that are possible from chemical bonding here, because these are also few questions asked previously. Look at this, chemical bonding and molecular structure. What do you understand by hybridization? Okay, and explain different types of hybridization involving s and p orbitals. Okay, so what do we mean by hybridization first, and the next explain different types of hybridization using s and p orbitals. Okay, very easy. Look at here. See, hybridization is a process of mixing of atomic orbitals of nearly equal energy in an atom to form new orbitals of equal energy called hybrid orbitals. So what they will do? So simple, very simple, just listen to me, I will explain you. See, Hybridization is a process of mixing of atomic orbitals. It means, look at here, I am saying methane molecule is there. So now what is the hybridization of this methane molecule? If someone asks you, what to do is just take the central atom here. What is the central atom? Carbon. No? Write its electronic configuration 1s2, 2s2, 2p, 2 we are writing right now. Like this you write. After writing, now the valency orbitals here. What are the valency orbitals here? These are the valency orbitals, like highest energy orbitals, highest shell orbitals are this one only, na? See 2, 2, yes, this one only. So just mention them like the boxes here, right? Okay, these are the orbitals. How many electrons are there here? 2. And here how many are there? 1, 2. Like this we can fill the electrons. Now after this, what they are saying, see, hybridization is a process of mixing of atomic orbitals of nearly equal energy in an atom to form new hybrid orbitals of equal energy. Okay, see how many bonds are required to make 4 hydrogen atoms to attach with the carbon? There are 4 bonds required to make 4 bonds with these hydrogens right now. So it means 4 unpaired electrons are required. So these unpaired electrons are possible by intermixing of this atomic orbital. Why do we need to intermix the atomic orbitals? When we mix this atomic orbital, see 2s 2p, there is slight difference in their energy. Now what happens is this 2s and 2p orbitals will be intermixed. It means they will overlap, I mean they will combine. After combination, they will redistribute their energies. It means before mixing they will be having difference in energy, but after mixing all of them are having same energies now. So when they redistribute their energies, now all of them have equal energy. Now instead of separating them, now you can mention them in this way. I am writing all 4 boxes together. It means 1, 2, 3, 4, 1, 2, 3, 4. When 4 atomic orbitals are hybridized, you will get 4 hybrid orbitals. What you can say? 4 hybrid orbitals. So now these hybrid orbitals are having equal energies. When there is equal energies, the 2 to 4 electrons are there now, that should be filled like this, 1, 2, 3, 4, like this we should fill the electrons. See, in previously you are filling 2 electrons in s orbital only. Now the one of this s orbital electron is getting shifted into the p orbital, so that all these orbitals are having 1 electron right now. So this is how hybridization takes place. Next what happens is, so now these hybrid orbitals are identical in shape. Now whatever you are saying, what is the name of this orbital? You should not say this as s orbital, you should call it as sp3 hybrid orbital. What you should call? sp3 hybrid orbital only. So how many sp3 hybrid orbitals are there? 1, 2, 3, 4. So 4 sp3 hybrid orbitals are present here. Okay, like this you should say. Okay, once after doing up to here, so now say what they are saying, all of them are same now, sp3 only now. So that's why they have identical in shape and they have equal energies, all of them, and they help in the formation of stable covalent bonds. What is the help of this hybrid orbital? They will be helpful to form stable covalent bonds with these 4 hydrogen atoms by this carbon atom. These are the hybrid orbitals of this central atom, that is carbon atom. Okay, now this 4 hydrogen atom will make 1 bond with one of this electron, unpaired electron of this carbon atom. That's it. Okay, so now types of hybridization involving in the during this process with the help of s and p orbitals. Okay, see, if only one s, one p orbital is involved, simply you can say sp hybridization. So sp hybridization means what? Mixing of one s orbital and one p orbital is called sp hybridization. Okay, now 2 identical sp hybrid orbitals are formed. Now these orbitals arrange linearly. How many orbitals are there? Only 2 orbitals are there now. So one orbital will be oriented in this way and another orbital will be oriented in this way, because we need to keep that orbitals maximum separation, with maximum separation. See, if I keep like this, what happens? Tell me. See, if I place like this, what happens? See, orbital is nothing but electrons only now. These are nothing but representation of electrons only. electron density. If these electrons are very close to each other, electron negative charges now, like charges repulsions takes place right now. So to avoid these repulsions, we need to place the orbitals every time with maximum possible separation. Okay, so here 2 orbitals only possible, so the maximum possible separation is 180 degrees. That's why sp hybridization will get a linear arrangement. How they arranged? Linearly. Okay, how do they arrange? Linearly. Okay, and after that, what is the example you can mention? Beryllium chloride is example for this linear hybridization. Okay, linear molecule. The electronic configuration, see, beryllium chloride we are studying now. So in this beryllium chloride, what is the hybrid, like what is the electronic configuration of beryllium? Atomic number is 4. You can write 1s2, 2s2, so 4 electrons are over. So highest orbital with how many electrons? 2. After these you have 2p. 2p is in 0 electronic configuration. Okay, you can mention 2s, 2p. How many electrons are there? P 0. 2 s orbital is 2. So one here and other one here like this, and this is empty. Now what to do? So the one electron from here will shifts into this, that is what hybrid orbitals are formed here like this. So what is the hybridization involved here? So 2 orbitals are undergoing mixing to generate 2 orbitals. Why do they require 2 orbital generation? Because how many surrounding atoms are there? 2 surrounding atoms are there now. So each one should be requiring 1 unpaired electron like this. So that these 2 unpaired electrons here will be getting pairing up with chlorine atoms like this. Okay, so beryllium at the center, this side 1 chlorine and this side another chlorine. So what is the angle between these two? 180 degrees. Okay, so you can imagine that in this manner. Okay, linear molecule with bond angle 180 and beryllium at the center. This is one s orbital and like sp orbital, this is another sp orbital of beryllium, and this is green color representation for chlorine. Like this you will get a sp hybridized molecule with the help of s and p orbital of beryllium. Okay, so now next one is sp2 hybridization. So this sp2 hybridization is possible by mixing one s orbital and 2 p orbitals. By mixing what? One s and 2 p orbitals. Okay, so now what happens when they undergoing mixing? They will form hybrid orbitals. So what is the hybridization now? S2p, that is sp2 hybridization you will get. What you will get? sp2 hybridization. Okay, so now how these sp2 hybrid orbitals are oriented? So 3 orbitals now. So 3 orbitals means at the point here. So in the, just imagine in the spherical shape, like a spherical shape, like 3-dimensional view, try to arrange these orbitals in the 3-dimensional manner with maximum separation. Yes, you can place them in this manner. So now what is the separation angle here between them? 120 degrees right now. So for sp2 hybridization, what is the angle possible? 120 degrees. Okay, remember this point also. Now read this. Orbitals arranged in trigonal planar manner. The best example is BCl3 trichloro boron trichloride. What is that? Boron trichloride, BCl3 or BF3 or AlCl3. These are some examples of sp2 hybridization. Okay, next here also whatever we discussed. Now how many valence electrons are there with the boron? So it contains 3 valence electrons, like 1s2, 2s2, 2p1. Okay, so these are the 2 electrons in S and 1 electron in P. Okay, now what happens? See in BCl3, how many surrounding atoms are there? 3 now. So 3 unpaired electrons are required. So it means it will undergo overlapping or intermixing and forms like this. So what is the hybridization we are getting here? So this will be, by shifting here you will get sp2. Okay, so this is one with 1 chlorine, this is another chlorine, and this is with another chlorine. So like that they will make 3 bonds, so that we got sp2 hybridized molecule with this structure. Okay, right. What is the bond angle here? You are seeing 120 degrees. That's it. Okay, hope this is also clear. Similar to this, we have sp3 hybridization. What we have? sp3 hybridization. How this sp3 hybridization possible? Just now we just started discussion of hybridization using methane molecule now. So methane is best example for sp3 hybridization. Now carbon contains how many unpaired electrons? First of all, it contains only 2, but we required 4 bonds to make, right now. So 4 unpaired electrons should be made here by exciting the electrons of 2s orbital to the 2p orbitals, that is intermixing of s and p orbital. We will be getting 4 unpaired electrons. Now each of this electron will get paired up with 4 hydrogen atoms, because 1 electron with hydrogen, 1s1 electronic configuration now for each hydrogen atom, that 1 electron of hydrogen and 1 electron of this carbon will get paired up and making 4 bonds in this way. Okay, so that you will get a methane molecule like this. So what is the geometry here? You can call the angle, the bond angle here is 109.28 minute. Okay, 109 degrees 28 minute, you can say 109.5 degrees or 109 degrees 28 minute. Okay, 109 degree 28 minute you can say, or 109.5 degrees you can say. Okay, this is a bond angle. And what is the name of the geometry? This is called tetrahedral. What is that? Tetrahedral. Okay, that's it. Okay, so these are the points to be remembered by each and every student. You need to represent it in this way definitely to get a good marks. See how many sigma bonds? 1, 2, 3, 4. Just read these statements. Read these statements and try to represent in this way only. Again, if you want these materials, directly download it from our NEET World app from the Play Store. First go to Play Store and download NEET World app and access this free content. Okay, right. And see guys, those who are new to this channel, just click on the subscribe button, and if you are really following us, you can share with your friends, those who are preparing for IPE as well as EAP set. Okay, because in every day we will be making for each and every subject, we will be coming up with one EAP set session that is also useful for NEET and JEE preparation also, and one more session is for your IPE discussion. Okay, so these are the 2 sessions are conducted every day in our NEET World free live sessions. Okay, so you can access them and you can make your preparation more productive and more effective and score very good marks, and you can thank us later. Okay, but as of now, please share with your friends and also with the like juniors and seniors, so that their preparation also get very easy. Okay, thank you for watching. Stay connected with us. Thank you.